Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today we are going to study about the fourth case of Vsepr theory, that's valence shell electron pair repulsion theory. And in fourth case, we will deal with the comparison of bond angles within a molecule on the basis of repulsive forces between the multiple bonds and the single bonds. For this concept, I am taking the example of the compound with the molecular formula of AB2, and let's make its three different cases. Let's talk about the first case, that's the central element A, which is forming single bond with the first B and again single bond with the second B. Let's come to the case number 2. Here we are having central element A, which is forming double bond with the first B and a single bond with the second B. Now let's come to the case number 3. That's again central element A, which is forming triple bond with the first B and a single bond with the second B. Now let's discuss about the case number 3 first. In case number 3, we are having one triple bond and one single bond. Whenever there is a presence of triple bond, then out of that bonds, one bond will be sigma and the another two will be the pi bonds. So the pi bonds will have the pi electron cloud over itself. So we got the pi electron cloud. So this pi electron cloud will repel this single bond very strongly, or we can say the pi electron cloud of the triple bond will repel the single bond very strongly. So I am writing pi electron cloud of triple bond will strongly repel single bond, or we can say the sigma bond. So here we are having maximum repulsive forces between triple and single bond. Now let's come to the case number 2. In case number 2, we are having one double bond and one single bond. Whenever we are having the double bond, out of that bonds, one bond will be sigma and another will be the pi. Here we are having one pi bond. So the pi electron cloud will be there, but with a less electron density. So here pi electron cloud is there, but the electron density is less as we are having only one pi bond. So this double bond will again also repel this single bond, but with less force or less efficiently as that of the case number 3. So here I am writing, we are having pi electron cloud with less electron density comma, so repulsive forces will be there. Will be there between double and single bond, but comparatively less than case number 3, which we have just done. Now let's come to the case number 1. In case number 1, we are having just two single bonds. So they will be the repulsive forces, but the magnitude of repulsive forces will be minimum. As we are not having any pi bond, so there is also not any pi electron cloud. So here in this case we are having minimum repulsive forces. Minimum repulsive forces between two single bonds. So what's gonna happen according to these repulsive forces? Let's talk about the case number 3 first. In case number 3, we are having the maximum repulsive forces between the bonds. We are having maximum repulsive forces, due to which what's gonna happen, the bond angle will expand. Due to the maximum repulsive forces, the bond angle will expand. So in case of triple bond and a single bond, we will be having maximum bond angle value. Due to the high repulsive forces between the triple bond and the single bond, we will be having maximum bond angle value. Now let's come to the case number 1. In case number 1, we were having minimum repulsive forces. We were having the minimum repulsive forces. So in this case, we will be having minimum bond angle value also. Minimum bond angle values. Because the bonds are not repelling each other. If bonds are not repelling each other in case number 1, then the bonds will stay close to each other, thereby decreasing the bond angles. So in case number 1, due to the minimum repulsive forces between the two single bonds, we will be having the minimum bond angle values, as both the bonds will not repel each other, due to which both the bonds will remain close to each other, due to which the bond angle will be less, or we can say decrease. Now let's talk about the case number 2. In case number 2, we are having the repulsive forces intermediate to that of the case number 1 and the case number 3. So the value of bond angle. So the value of bond angle will be intermediate. To that of case number 1 and case number 3. So that's all about the fourth case of the Vsepr theory, the valence electron pair repulsion theory. So now let's apply this concept on an example, on a real example. So for this concept, I am taking the example of phosphorus oxychloride. That's POCl3. Let me draw its structure, its geometry, which will be tetrahedral in shape, because phosphorus in POCl3 is sp3 hybridized. So the geometry will be P, that's the double bond O, that's the first chlorine, that's the second chlorine, and that's the third chlorine. Now what I have told you, what I have just taught you, this double bond will repel this single bond more effectively. So this repulsive forces will be maximum. Again, this double bond will repel this single bond more efficiently. Just imagine this in 3D, and this double bond will also repel this single bond more effectively than single bond. Due to which what gonna happen? Due to which, first of all, let's mark this bond angle to be theta 1. Now, what's the normal tetrahedral angle? The tetrahedral angle is 109 degrees and 28 minutes. So in this case, the double bond is repelling single bond strongly. I am writing here we are having strong repulsive forces. Here we are having strong repulsive forces between double bond, that's P double bond O, and single bond, that's P single bond Cl. Due to which what gonna happen? The value of theta 1 will exceed the standard tetrahedral angle value of 109 degrees and 28 minutes. So in this case, the value of theta 1 will come out to be nearly 112 to 113 degrees. Now, as in this case, there are strong repulsive forces between the double bond and the single bond. So, we are having again the lesser repulsive forces between the single bond and the single bond. As the magnitude of repulsive forces between the double bond and single bond is greater than the single bond. So, let's talk about the bond angle between the two single bonds, that to be theta 2, or we can say the angle is theta 2. You can imagine it in 3 dimension as the theta 1, as the value of theta 1 increase, it will cause the constriction or decrease in value of theta 2. So, why this is happening? Because the repulsive forces between the P double bond O are between the P double bond O and the P double bond Cl are greater than the repulsive forces between the single bonds, that's P single bond Cl and the P single bond Cl. I am repeating it again. The repulsive forces between the P double bond O and the P single bond Cl are greater than the repulsive forces between the P single bond Cl and the P single bond Cl. Due to which what's going to happen? The value of theta 1 will exceed the normal tetrahedral angle of 109 degrees and 28 minutes, and on the other hand, the value of theta 2 will decrease than the normal tetrahedral angle of 109 degrees and 28 minutes. So I am writing the value of theta 2 will decrease than the normal tetrahedral angle of 109 degrees and 28 minutes. So the value of theta 2 comes out to be 103.3 degrees. So that's all about the case number 4 of the Vsepr theory. I'm repeating it again. As you can see the geometry of POCl3 in 3 dimensions. Just try to imagine this geometry in the 3 dimensions. Then you will realize that the P double bond O is repelling the P single bond Cl, all the P single bond Cl strongly, due to which what's gonna happen? The value of theta 1 will exceed the standard angle of 109 degrees and 28 minutes, and the value of theta 2 will decrease than the standard tetrahedral angle of 109 degrees and 28 minutes. So theta 1 comes out to be nearly 112 to 113 degrees, and theta 2 comes out to be 103.3 degrees. So that's all about the case number 4 of Vesper theory. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on the thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Please do press the bell icon to get the regular updates on my YouTube channel. Stay blessed.